So in estimating, always the question is how much and how long. So what we want to know now is how to use what's known as velocity to answer that question. We're always being asked how much and how long. That's the economics of software development. How much is it going to cost me and how long is it going to take? Because that's what drives the funding. And we've talked about the algorithm for estimating. First step, discover how big it is. And then the second step is to answer that question. For a program of this size, or for a story of this size, or for whatever we're going to build of this size, how much is it going to cost and how long is it going to take? So we've spoken about relative sizing, and we can come back and say, there's 120 points in the backlog. And that tells us how big the thing is. That's how big our work is. But a lot of people who are asking that question, how much and how long, are going to ask, well, geez, that's really sweet of you, 120 points. I need to know in dollars and in time. So how do we convert that 120 points or that size estimate into something that we can take to the bank and answer the question, how much and how long? Well, this is where the term velocity comes into play. And velocity is the cool, agile term that describes how much work a team gets delivered in a sprint. So velocity is defined as the points accepted per sprint. Okay, so that gives us an idea of how much work the team can deliver. Now, it's important to understand here, it is the points accepted in the sprint, not just what we tried to do, but the points accepted. So for example, during sprint planning, we're pulling in the ready stories. We have approximately 31 points that we think, yeah, we can get that done, and we're going to commit to the product owner. Unfortunately, due to circumstances, we're not able to get all the points done, and we deliver 26 points, and they're accepted. 26 points are accepted by the product owner. Well, that's our velocity is 26. So key here is that velocity is actually measured. And this makes a very useful trait of velocity, that it's not estimated, it's not forecast, it is using measured data that says this is historically how fast the team has been able to go. So we are going to use this information to forecast how much work the team could actually deliver. Yes, it is sometimes looking in the rearview mirror to forecast the future, but it is definitely a more solid and defensible metric to use than, for example, just simple dead reckoning. So one of the things that I recommend is that you calculate your velocity as a moving average. So this means you're going to need 3-4 sprints of data before you can say, yes, this is my team's velocity. So for example, here, after the first 3 sprints, we can see that the team is holding at about an average of about 28 points. And as we go into the 4th sprint, we seem to have dropped a little bit. But this is giving the idea of calculating the velocity as a moving average and be able to use that to say, look, if you are forecasting that we are going to be able to do 35 points in sprint 5, what has changed since sprint 4 when our velocity was 26 points? So this really gives you an evidence-based method for managing your estimates. So now how do we use velocity to answer the question, how much and how long? Well, we can simply say how long it's going to be by saying, well, how many sprints? If we know that velocity is the amount of work we can get done per sprint, then what we're going to do is take the total points, divide that by the velocity, and that gives us the number of sprints. And then if you want to turn that into calendar time, basically what you're going to do is say, well, a sprint's 2 weeks, so therefore this is how long it's going to take. What's your total cost then? It's the cost per sprint. And you know that's fixed, right? The team is of a fixed size, so the cost per sprint should be fixed. Sprint 1, Sprint 2, Sprint 3, each sprint should cost roughly the same, unless you're doing a lot of rebalancing the team, which is inadvisable in the Agile world. So let's take an example. How much and how long? How would you work it out? Well, this is the way I might approach it. Okay, so let's assume we've got 120 points of work on our product backlog. And we know that our best velocity has been 30 points, right? There's always variations, some variations in velocity. So we say our best velocity has been 30 points. Our average velocity, about 25, and our worst is 15. So, and the other thing too, let's assume the cost per sprint's $100,000. Now that's kind of based on the assumption that you have 8 people dedicated to a team, and they've got a fully burdened rate of approximately $150 per hour, and that you're running a 2-week sprint. Yes, that's what 2 weeks may cost you. It actually is, I'm willing to wager that if you crunched your numbers, you're going to find you're pretty close to that $100,000 per sprint number. You might be over, you might be under, but yeah, a sprint is expensive. So you want to make sure you are focused on value. So here's how the calculations might work. At our best velocity, the green there, to do the 120 points, we're looking at approximately 4 sprints. At our worst, it's going to be 8. And the cost, well, if it runs $100,000 per sprint, at our best, the green, it's $400,000 to do the project. If we're running at our worst pace, it's going to be about $800,000. So this gives you a way of coming up with a bracket to answering the question, how much and how long? At our worst velocity, we know that it's going to take us 8 sprints and $800,000. If we're able to sustain our best velocity, then it's going to be 4 sprints and $400,000. Now, of course, when you give this information to your CIO, she comes along and says, well, that's awesome, but the budget is $400,000. So it's no longer how much and how long, it's what can you do within this constraint of the $400,000 budget. So how do you answer that question? Well, the question is now, how much work can we do? So what we want to know then is how much funding do we have for the sprints? So the number of sprints we can do is our budget divided by the cost per sprint. And therefore, what we can deliver is based on our velocity and the number of sprints we have. So how many sprints can we run for the money that we're given, and how many points can we deliver per sprint? So let's see how much we can do. Let's again use our example. We have a $400,000 budget. We know that our cost per sprint is $100,000. It's a fixed cost, right? We have a fixed size team and a fixed size time box. So at our best velocity, we know that we can run 4 sprints. $400,000 gives us 4 sprints. We can run 4 sprints and deliver 120 points. We know at our average velocity, we can run 4 sprints. Each sprint delivers 25 points, therefore we deliver 100 points. And at our worst velocity, again, we run 4 sprints. Each sprint delivers 15 points. We can deliver 60 points. So that gives us an idea of how we can use velocity to translate the size and of the work that we have into answering the question, how much and how long. As a final point that I will leave you, velocity is always a great input for calculating how much work a team can pull into during planning. So this is really, I sometimes refer to velocity as your bucket size. How big is your input bucket? How much work can the team reasonably pull into the sprint and make an honest commitment to their product owner? So tracking velocity is really, really quite important for managing your agile teams.